is going to show you how to derive the expression for viscous damping coefficient, viscous damping coefficient C. So what is C equal to? Okay, and it is very useful method because damping is involved when there is a thin film between the bearing and the housing, thin film of oil, and or in the shaft is rotating in the housing, or if it is sliding on a straight line, like in this case this is a plate which is moving. Okay, this plate is moving with the speed of v. So it's as you go from, you know, the shear stress, the shear stress is in the fluids. This is a little bit, you have you taken fluids dynamics before? The shear stress is mu, which is the viscosity, times the velocity of the fluid. So initially the velocity points at this location are, when it is at near the surface, it is, the velocity is the zero. Okay, but as you move away, the velocity keeps on increasing. U becomes v. U becomes v when the complete distance y, when y equals to d, u becomes v. Okay, so you see this plate is moving with this velocity v. Okay, now what happens that the the viscosity, let me show you the just a side knowledge that the viscosity, you see honey and gasoline, honey is very thick, gasoline is very thin, so gasoline moves very fast. So what will happen that the shear stress, the viscosity is very low. So du over dy means for this this speed, the denominator, if I take gasoline, the denominator, the speed is very high. Okay, the denominator, shear stress in the numerator, denominator the velocity of the gasoline, and when it is very high, the mu goes down when it is very high because it is in the denominator. What is this? U equals to y over d times v. As y becomes d, that u becomes v. Okay, now shear stress is maximum at the top layer. Okay, it is maximum at the top, greatest at the top layer. It is zero at the surface. And now tau shear stress is force per unit area. And what is force? That means force equals to tau times area. Agreed? And what is the force of a damper? C times V. This is the combination. And this force equals to tau A. Okay, what is tau? Tau equals to mu du over dy times A. And what is du over dy? Du over dy, it is also equals du over du over dy equals to v over d. So you can plug in v over d from that equation. So mu v over d area, it is equals to tau area, correct? And this is equal to the force. So force equal to cv. Cv equals to mu v over d. V is cancelled by this v, so you are left with, I'm sorry, there is little error. This cannot, I'm not, this f equals to, so let me write down this, just forget about this one. So f equals to, since time is short, I'm just a little bit confused here, so let me write down here this f mu. So I can write down f for this force equals to mu times vd over a, and then v is cancelled, so you are left with c equals to mu a over d. We will move forward from here next time. Okay guys, I'll see you next time. Thank you.